So for the final topic, we're talking about automating the loading of a tempering line and how we can also optimize what kind of loading patterns are created. So the speaker is Mauri Saksala from Glaston. Mauri has decades of experience from the glass industry. I think he has done business in close to 100 countries over the years, seen numerous factories around the world. And now, Mauri, stage is yours.
Thank you, Riku. Yeah, been around, seen hundreds of factories, and there is one common thing with all of them is that they are all different. So anything which is needed to be done, needed to be developed, is typically case by case. There are similarities, but still, whatever you need to do, whatever you need to develop, what kind of measures need to be taken, it depends very much on the type of production, even within a production year. But the common thing currently is added automation. There are certain drivers which are, I think they are rather obvious, but I wanted to list them here so that we see that they are eventually small creeks, but they create great rivers. So the labor generally, okay, the first always is the cost. People find that there is you can have a cost savings when you have labor minimized. But it's not only the cost, it's also availability. Surely related to the costs eventually. Stability. There are quality matters, people do differently. Some people are more careless than the others. And then people get sick. They have absences, no question about it. Then another very much human-related item is idling. And now as we are talking about tempering furnace, we talk about mist loadings, which means that there is a furnace ready, everything is ready, correct temperatures, correct recipes, but nobody is pressing the loading ready button. Nobody is sending the glass to the process, to the furnace. Surely it can be due to the production control, which is not in an optimal level. There is not enough glass or whatsoever. That's very, very common and very understandable. But it also can be lunch. It can be a bio break. Cigarette, chat with the guys. Then some people they are not in a hurry. It's very human, very human. You can minimize maybe some, but you can never get rid of all of them. And then when pairing this, I would say these two first ones are rather general to the whole process and process related actions. But then the bed utilization is for tempering furnace itself. How much glasses you can put on a bed, how to put them there so that the rules of tempering furnace are fulfilled at the same time. So all in all, I can claim, based on my experience, based on the statistics, what I will show after a while, production is wasted a lot. So quite often people think they have kind of pink ideas of what is the efficiency in the factory, but the statistics will show something else. We have done some evaluation of in furnaces what we have access, which are connected to the cloud. 98 furnaces since 2016, 6.3 million loadings, 38 million glasses, and the average bed utilization rate is 37%. And this means that some companies, they have less, they have 20. Some companies may have higher, especially if the glass sizes are close to each other and rather small sizes. But typically in a mixed production, you can easily get 37 and very often lower than that. But that's not the only thing. The production can be wasted also by idling. Now this is kind of imaginary factory, but Maybe some of you are doing 200,000 square meters glass, and then if they are equal amount for 6 and 8 millimeters, furnace size 2.8 by 6, and you are doing 2 shifts. Increasing the loading bed efficiency to whatever it is in the beginning. But if you can reach 46.5, I remember correctly, 46.5, you can omit the second shift. This level, of course, depends very much on the type of production, on the type of factory, but the limit is somewhere. And this is something that I recommend to be evaluated. Then the idling itself, it is difficult to evaluate because it varies a lot. It varies a lot between the companies, between the production time. There are high seasons, low seasons in a production, but it's quite typical that there is a remarkable idling time, and this idling time can be a process time. Maybe not all of it, but part of it. And on top of everything, if the very same company doing 200,000 annually can improve the loading bed utilization from 25 to 45 with these figures, 15 euro cents per kilowatt hour, the saving is 79,000. If it is from 25 to 35, it's less than that, but this is directly to the bottom line, whatever it is, and depending how much you eventually save and what is the kilowatt hour price locally. But improving is possible. There are many ways to improve it, and I want to emphasize that no one should aim to the perfect situation. It's just okay to have a little bit here and there, and you can gain rather remarkable result. But why this has not been done earlier? It is, I have to say, rather challenging. I've been around for more than 30 years and I've seen some simple automation, but it has not been possible to have mixed production automation or batch optimization. And the characteristic of process is that after cutting, during the cutting, glass is optimized. And ever since it is traveling as one piece of glass. It has an ID number, it is recognizable during the process flow. But then in flat tempering they are collected together, but you cannot collect them any way you want. There is a certain way how to put them on a table. And after that tempering they continue to laminating IG customer directly. So in order to maintain the batch and create the most efficient batch, we need to have information from the process flow, ERP, MES, PPS, whatever you call the system. Companies typically have kind of ERP or manufacturing execution system where the glass information is all the time alive. So once this information can be received, and of course, if necessary, some remake information can be put back, then we can create an algorithm. And during these last couple of years, we have done heavy software work to create an algorithm which has to take into the consideration furnace type with some fixed matters which are which need to be evaluated once. So furnace type, furnace year model, what options are included, how it is organized whatsoever. But then there are variables which are, even the furnace remains the same, the production is varying, quite obvious. There is a different kind of reasons. You want to focus on the capacity, so you increase the heating time and you will get higher capacity but less quality, and then you can do vice versa. All this has to be taken into consideration. Also environmental conditions are affecting to the parameters needed, and then the furnace specific rules how the loading bed can be optimized. Time is not enough to really open up what kind of AI, what is the algorithm basis, but the basics are that algorithm for tempering load optimization receives the information from the production control system. So this information is there and it needs to be received. And it has been already checked that it's business as usual. People just need to agree how to do it. And then, as simple as it is, it's very couple of words here, but as said, it's quite many lines in a code. But the essence of the whole is that the algorithm is connected to the furnace automation, and this communication interface adjusts the process parameters automatically. So system needs to know what type of furnace, what type of production, what kind of conditions, and this is adjusted automatically and on the run. And then once the batch arrangement data, it can be also utilized with robotic solutions. So the algorithm has different possibilities to be as a guidance for the operator, or it can control the automatic loading system, whatever it is, arm robot, some conveyor system, whatsoever. And the important is that you should be able to mix the loadings, mix the orders. So anyone who have seen tempering furnace operation have seen different kind of loadings. Morning shift is doing different way, evening shift different way. Then there are certain operators, they want to do this way. Some say that with our furnace, this has always been the way. We cannot do good quality if we don't put them this way. Algorithm is now calculating based on the information what is on the glass racks, and calculates based on the tempering rules, as you cannot put the glasses on the table whatever you want. They must be in a certain order and with a certain pattern. Surely it will work also if you are not mixing the orders. Whatever you can do to improve the loading efficiency, you can gain benefits, as I explained earlier in the previous slides. And now when you mix the orders, then it is naturally important that you see also in the unloading end which order belongs to which glass rack, or which order they need to be put to the conveyor, whatever is the unloading. So this information is available once the loading information is available. Then once the geometry is known, we know the glasses, we know their size, shape, thickness, it is also possible to control an automated loading system with this information. So the coordinates are known, you know the coordinates of the loading table, you know the coordinates of the glass, whether they are on a conveyor or glass rack, it is possible to have a fully automated system. So this is the most boring system. Nothing happens but loadings. So this works the same in whether it is Monday or Friday, winter or summer. And I recommend that if selecting an arm robot, you should select a non-smoking model, so it is not even having a brakes for that. And once it is fully automated, it is possible also to put the glasses in a way that the operator has difficulties. First of all, the accuracy itself, but also if there are empty area, you can just optimize the loading by putting the last one in the opening in the loading table, or from the glass racks. So the characteristic of the rack system is that you can't take the second glass before you have taken the first one first. And this need to be calculated. And the algorithm is doing 600,000 calculations for each batch that need to be optimized. It's like a little bit like playing chess. You need to think advance. Once you move one, you need to think about the consequences. And this is what I think it's very important to target. Boring loading. It's nothing, no dramatics happening. It's just doing the job. So, as said, wasted production. It is wasted more than people realize. Everyone in a different way, different time of the year, different way, different time of the economical situation, it's a different way, but there are a lot of ways to improve and a lot of places to target the improvement. So I like to end up my presentation just by stating that improving the production efficiency is possible.